Morning, everybody. Welcome to, I think this is the second week of our ongoing open house. A little background for the Ascent open house. Obviously, with the coronavirus pandemic sweeping through the world, many events and conferences have had to be canceled. We wanted to create just a space where we could recreate conversations that might have been had at those events and conferences, share ideas, connect up with people, that kind of thing. So we created the Ascent Open House. We've been doing, as part of that, a series of these virtual fireside chats, we're calling them. We had a number last week. We've got a few more this week and even a couple more the following week. I'm really excited about today's, where we're talking to Spencer, our VP of Data Science, about creating data certainty in uncertain times. So Spencer, just to sort of start us off here, one question we often hear from our customers is about how we can make sure that the information they're getting is accurate. Obviously, we're working with these giant data sets that are too large to be manually checked, right? So can you just walk us through a little bit how we're able to have confidence in that data, considering we can't manually check every part of it?
Yeah, thanks, Marcus. I'd love to. So I think to contextualize this answer, it's important to think about what we're trying to accomplish at Ascent. So Ascent is essentially building technology that scales knowledge work. Traditionally, a lot of the work that is done in compliance has been domain experts that are manually reviewing information that regulators are releasing and then making decisions about that information. And much of that process, there are parts of that process that are kind of critically important. High-level thinking, creative, kind of domain expert steps that need human review, and then there are other parts of that process that are, much more kind of rote steps that are just about moving information from one place to another or making small transformations, and so on. And so, as we think about scaling this knowledge process so that we can help our customers do a lot of that work, but across regulators and stay up to date and deliver all the different kind of value that we as a company deliver. We think about accuracy across this kind of scaling in those individual steps. So it's really important to us to break this kind of knowledge process down into discrete steps so that we can evaluate the quality of our work and of our automation at each of those steps. When we break it down like that, then we can start to apply, a relatively simple risk framework to these different steps. And we can think about, for any given step, what level of accuracy or what level of quality do our customers need to be successful, right? Knowing that even a fully human process, and status quo now, will likely have some error rate. How can we make sure that for the most critical steps that require as close to 100% accuracy as possible? It's basically a kind of quality risk framework. And so for steps where missing something would be a big problem for a customer, we spend more of our resources both programmatically and manually to make sure that we achieve very, very high quality there, as close to 100% as possible. And in those cases where we've tested it against a fully manual process, we do better than a fully manual process, actually, because we're using both humans and programmatic technology to achieve this outcome. And then on steps that are maybe less critical because it's just an added feature to help find a document or something that is kind of less important for achieving your compliance goals, we're able to scale those faster and accept a lower quality, because it still meets our users' needs, basically. So I think that's the beginning of the answer to your question, Marcus, about how can we ensure quality even at kind of massive data, is we can target our resources appropriately to make sure we get
Yeah, sorry. I think unfortunately you're starting to cut out a little bit at the end again there, Spencer. We'll see. Okay, I think you're back with us now. I know one way I do, and CEO talk about it too, is like think about like with self-driving cars, right? So with self-driving cars, there's certain steps where like if you're taking a left turn into oncoming traffic, you want to have really high certainty that the self-driving car is going to be able to execute that step. If you're like parallel parking, you don't need quite as high a certainty. A bump against another one is okay. And I think, thinking about the same kind of way of what we do here, right? Like risk compliance teams have some of these steps where like we have to be really, really certain that we're doing it correctly, because it's huge for their business, where other ones are not necessarily as necessary. And you talk for those certain steps, we couple it with like it's human domain expert, right, to like make sure we are able to meet that need.
Yeah, so a great example is we have a pretty important step in our process where we take the original text of a rule set from a regulator, and we break that text down into the specific obligations that make up that text. If we were to, for example, miss an obligation, that would be a big deal for our customers, right? Our customers are relying on us to give them a full and accurate list of obligations that they need to follow. So for that step, not only are we using technology, including machine learning and other things, but every kind of prediction that's made by a model, every result that goes through our process is reviewed by a lawyer to make sure that the process we're doing is yielding as close to perfect results as we can get for that step, because it's so critically important. And even though we still have a person looking at these steps, we're still able to achieve pretty dramatic efficiencies over kind of the traditional way of doing things because of all the technology that's supporting them. So we are able to maintain that kind of really high level of quality, but also scale so that we can help our customers meet all of their compliance goals. But on the other hand, kind of to your parallel parking analogy, what part of our offering is that we provide thousands and thousands of documents to our customers from all different regulators. And one of the things that we do as part of surfacing those documents is we assign each one a type of document. So we say, oh, this is an enforcement action, or this is a guidance note, or this is a speech, or this is a press release. And actually those categories are categories that Ascent decided on internally from a product standpoint. So there's not really a legal definition. Our customers aren't necessarily relying on those kind of categories to do their jobs effectively. It's just something that helps us kind of filter these documents a little more effectively and surface them to our customers a little bit more efficiently. And so there, if we label something, let's say a guidance note, when it actually was a press release, it's not the biggest deal in the world. They're still able to be found under the proper author or regulator. They're still in our system. Our customers can still free text search within them. So we spend less of our kind of precious domain expertise time on getting that 100% compared to something as critical as making sure that we deliver all of the obligations that our customers need.
Yeah, definitely. And you talked to me about this before too, right? Like, so one of the cool things about machine learning is that like, as our, domain experts go through and help, determine, what is an obligation, what isn't, where the computer might have a question, that trains our machine learning systems to learn more so that they get better as it goes on, right? So that the amount of time that we need for those domain experts is decreasing.
Exactly. And so one way to think about that is anytime we're using a machine learning model, many machine learning models have a probabilistic element to them, meaning that when they produce a prediction, we can assign some probability that prediction is actually true based on kind of how the model understands its representation of the world. And we can also make the same prediction many, many times and look at the distribution of those predictions. And if a model is very confident in its prediction, then it should actually have a pretty stable distribution if you repeat that prediction many times. And it also confidence that that's correct when what kind of confidence score. Whereas if we're encountering a prediction that it's maybe less sure about, then we would see a much wider distribution if you make that same prediction many times, and we would see lower kind of confidence levels in the way that it evaluates its confidence. So what we can then do is kind of divide these predictions into different tranches of low, medium, and high confidence, so to speak. And we can control the actual accuracy of each of those tranches. So we can say that anything we're marking as high confident, we are defining high confidence as kind of the level of prediction above which we are 99% accurate, right? And therefore, we can know that anything that our machine learning model puts in that high confidence bucket, taken together, we achieve 99% accuracy there. And we can just pass those through without domain review if per that kind of earlier knowledge risk framework, we're comfortable with the 99% accuracy rate. And so as our models get better, the percentage of predictions in that top high confidence bucket gets larger and larger until, theoretically we get to where every prediction is in the high confidence bucket and our whole model is 99% accurate. But even if the overall model is, let's say, 70% accurate, we can still, maybe we have 30% of predictions in that high confidence bucket, and that lets us cut out 30% of our time and still kind of scale across these huge data sets.
Yeah, I think there's this really interesting parallel, right, between like how, these emerging technologies, machine learning and stuff, how we couple that with domain experts to create our solutions, and how also like, our customers do the same thing, right? They take our technology and they don't just, replace it. They don't replace people with the technology. They use it to supplement the work that they're doing, to help them do that higher level, more critical work and take over the more tedious stuff. I just think it's this interesting comparison where like we do the same thing, right? We're not just doing automation, we're doing automation with expertise, just like our customers are doing the exact same thing. Want to go on to, so another concept you talked to me about is model drift, right? So this is not something I knew anything about, but I think it was an interesting concept we talked about, where one of the risks of working with machine learning systems is model drift, and then how we control for that. Can you just kind of walk us through what model drift is and then what we do to prevent it?
Yeah, I would love to. So model drift is basically the idea that if the underlying process or data changes, then our models will become less and less accurate. So for example, if our models are trained on a bunch of US regulators, but suddenly we start adding in a bunch of European regulators, and the process by which European regulators create their rule sets looks significantly different from the way that US regulators do, then we would expect our model to not be as accurate on European regulators. So that's a dynamic that we are very aware of and incorporate into the way that we build our models and build kind of our automation pipelines. And so there's kind of two ways that we address this. One is ways where we kind of know ahead of time this is likely going to happen. So that, the geographic difference is a great example. We know when we're going to enter new geographies, and we can, make sure that we're front running our model development ahead of time, getting the right types of training data sets that incorporate the types of data that we want to make predictions on, so that our models are accurate across different types of data and different types of underlying processes. The other type is unexpected model drift. So there may be underlying processes that change that we don't know about. Maybe there's a trend in regulation that we're unaware of for some reason, and over the course of 3 months or 6 months, that a lot of the data that we see coming in looks a lot different than the data we've seen historically. The way we control for that is we are always evaluating the accuracy and the kind of quality of our models as they're in production. So even for models where we have very, very high accuracy rates, there's really no guarantee that that will remain the case forever. And so we maintain at least a small stream of human to continuously accuracy models, so that if our accuracy does start to drift, we're able to get ahead of it right away. So that's kind of how we think about model drift, and how we make sure that we're not kind of losing sight of the quality of our models as we go.
Yeah. So it's an interesting concept, right? Because like, obviously we're using historical data to train these machines, but trends are going to change. Things are going to continue to grow. And we have to find a way to keep up with that. That's something I never would have thought about, but definitely you can see how it's so important to making sure our technology is accurate.
Yeah, and I think the other thing is that as we do more and more of that, we actually start to get better at predicting some of those changes themselves. And so, the kind of total value that we can start to unlock from these regulatory data sets grows over time as we think about, not just what are the obligations and what are the documents, but what are these trends? What are the big clusters of different topics? I imagine, given the kind of the current environment, we're going to start seeing a big cluster of pandemic related regulation, even in areas that are traditionally unrelated to health. So those are things that are difficult to anticipate ahead of time, but because we can scale so fast, we can start to see kind of that show up in our data really, really fast.
Yeah, and you've talked to me about this too, but right, it's because we don't just have the data, we have the connectivity between the different data points, and that connectivity allows us to see so many more things that we wouldn't otherwise be able to see, like those emerging trends, just to name one example.
Right. Yeah, when we, when many different people are working on different parts of regulation across the world, then it's harder for them to kind of align what they're seeing with each other. But when we have one system that's looking at regulation across the world, then we're able to draw out some of those comparisons and relationships and similarities and differences much more effectively.
Absolutely. All right, so then finally, let's just talk a little bit about enterprise risk, how we control against that, what kind of internal controls we have in place to help manage for that.
Sure, yeah. So, up until now, we've been talking a little bit more about kind of the cost benefit from a business standpoint, or about some of the technical details behind probabilistic predictions. It's important to remember that both for ourselves and as we work with some of these larger financial institutions that have very high standards for dealing with enterprise risk, that we, our overall model governance policies, model development and validation processes are kind of up to snuff as far as the latest guidance, and that we're confident that not just kind of the data itself and the models itself, but the human process around creating these models and validating and checking these models is using a control framework that's effective, right? So we have spent time, even as a relatively early stage startup, building out our model development and validation policies and procedures, for example. So we have a document that outlines how we build models at Ascent, how we make sure that they're high quality, how we make sure that as they kind of exist in production, that they remain high quality. We have specific templates for the way we do model documentation. We have standards for the way that our kind of gating process works as model results get validated at different stages, and as we go from proofs of concept to prototypes to fully kind of productionized models. So I guess the long and short of it is that we're really being thoughtful and careful about how we use this technology. We're not just kind of throwing stuff at the wall and seeing what sticks. We're starting from a very kind of quality first, risk first perspective on what do our customers need to feel comfortable and to succeed. And then with maintaining that high standard, we scale our technology underneath that.
Absolutely. Yeah, I think it's really interesting to learn about all of the different work that goes into that. You've given me this analogy before where it's like, right now, risk and compliance teams, when they're doing something manually, they have one lever to pull to, try and reduce risk, which is just hiring more people, increasing staff. Whereas like using these automated technologies, you have all these different levers you can pull for each step of the process, right? Like you talked about, if there's a step that's really critically important, you can say, okay, we're going to increase the threshold where it has to be above 99%, otherwise we need to check it. We can decrease it over here, and it just gives you so much more flexibility to reduce the amount of risk you have without increasing your workload, decreasing your workload, in fact.
Right, exactly. I mean, the bottom line is that the problems that our customers are solving are the same problems that we're solving. But we are just making the investment in kind of the broader toolbox as you're talking about, so that we can do it a little bit more optimally and then provide that value for our customers so that they don't have to do everything manually.
Awesome. All right, everybody. Well, we have a couple minutes here before we wrap up. I want to just take a minute to open it up for questions. If anybody has any questions, feel free to just put them in the chat, or you can raise your hand and I can unmute you. I'm also going to drop into the chat a link to our open house page, so you can see past talks we've done on there. You can register for some free swag on there. And I wanted to plug a couple upcoming talks we have too. So later this week on Wednesday, we're going to have Behind All Good Decisions, How Risk and Compliance Can Use Data Smarter. And then next Monday, we're going to have compliance use cases and best practices, what your bank peers are doing that works. I think those are both really exciting. We have probably a couple others that we're adding to our open house in the next week or so as well. So be sure to keep checking that landing page for the most recent updates. All right, I'll give it one more minute here just to see if any questions come through the chat. If not, we'll be able to wrap up. All right, great. Well, Spencer, I really appreciate you taking the time to walk us through this stuff. There's also an article on our blog that Spencer wrote that covers a lot of the same topic. I highly recommend that too if you want a deeper dive into this. Thanks so much, everyone, for joining. Spencer, thank you again. I really appreciate the time.
Thanks, Marcus. Thanks, everyone.
Thanks, everyone. Talk to you later. Bye.